This video is over Lesson 60, Fractional Parts of a Number, Part 1, and Percent of a Number, Part 1. And this is for my 7th grade math class. So, math is a language, the language of numerical values. In order to be able to understand mathematics properly, we need to be able to translate from English to math and from math to English. So, today, ladies and gentlemen, there's a few different situations we're going to take a look at, and two vocabulary terms in particular that you're going to need to understand their meaning of. So here we go. When we see a fraction of a whole is a part of the whole, okay, so this could be 4/5 of 80, so 80 would be the whole thing, is, and then what? So in this case, we might have the question be this. Or we could say 4/5 of what is 80? Okay, that would be a different problem to solve. So this is kind of what we're looking at here. So whenever you see a problem like this, we're going to break this down into these pieces here. So the fraction, whatever your fraction is, for our formula, we're going to translate this as the letter F. F for fraction. Of. You already should know that of almost always means the same thing in mathematics. And that meaning is times. And I hope you can see my times dot clearly there through that green. Next up, a whole. So for our whole number, since it's the whole thing, we're going to represent that with a capital W. Is. You've been using is in mathematics probably since kindergarten, if not earlier, whether or not you realize it. So if you think back to kindergarten class, if you can remember that far back, and you were asked, what is 2 plus 3? Well, you probably responded, 2 plus 3 is. And then you gave your answer. So what you've discovered there is means equals. 2 plus 3 is 5. 2 plus 3 equals 5. So is means equals. And then a part of the whole, since we've only got part of it, we're going to represent that with a lowercase p. And so, ladies and gentlemen, when we have a fraction of a whole problem, this is our formula. If we plug our pieces in to the proper part of the formula, we can see then what the relationship is and then figure out what to do to solve. So, moving on to our next example here. A decimal of a whole number is a part of a number. So you could also see this. This is a little less common, but it's going to be the same basic formula. So this time I'm going to do a lowercase d, d for decimal. D for decimal. The of will be a times dot. We'll do a still capital W for whole. Is means equals, and then P for part. And then our last situation we're going to look at is a percent of a whole is a part of the whole. And it's the same basic formula. Only this time I can't use P for percent. Let's use C. C for cent. It is a percent. And then, of course, of means times in this case. The whole we're representing with a capital W. Is always means equals. And our part we're representing with a lowercase p. And there's our formulas. So, quick note here. In mathematics, is always means equals. And of almost always means times. So, now, ladies and gentlemen, I'm going to ask you to go ahead and grab your math books, please. And we're going to look at a few practice problems together. So I'd like you to please find lesson 60. So I'm pulling it up here myself. Lesson 60. And then we're going to take a look at the practice problems of lesson 60. So here we go. Lesson 60 practice problems are on page 423. 423. So, problem A. First of all, the directions. For problems A through E, translate each question into an equation. So we're going to do that. We're going to translate each question into an equation. So we're just going to start with translating. So A says, what number is 4/5 of 71? So if we think about our translations up here, so what number is 4/5 of 71? Well, you hear the fraction of the whole. So the whole thing here must be 71. Go back to the beginning. What number is? So that what number must be the part of the whole. So it's the part of the whole here that I don't know. What number? I don't know what number. So I can go P here, or you could go with the more traditional X. I'm going to go P for part of the whole. So what number is? Is, remember, means equals. Next we see 4/5. So we're going to write 4/5. 4/5 of means times. And then it says 71. 71 is my whole thing then. And ladies and gentlemen, that is my equation. Now, because the equation is set up like this, where my unknown equals whatever this is, I actually can just go ahead and start solving this. So with a fraction times a whole number, in order to solve this, I'm going to have to take my whole number and also turn it into a fraction. Which, ladies and gentlemen, if you remember, changing whole numbers into fractions actually is very simple. We just take them and we place them over 1. Now, this would be a good time to reduce before multiplying if we can. So remember, it's always a numerator with a denominator. Now, 1s can't be reduced. That's as reduced as you can get, so the 1's not going to help us out here. So can we reduce the 5 with the 4? Well, obviously not. They're both too small and too close. Can you reduce the 5 with the 71? And I hope you've said no, because you know your divisibility rules for 5. This would need to end in a 0 or a 5 to be divisible by 5. And since 5 is prime, it can only be divided by itself to be reduced. So, no, we're out of luck there. We're just going to have to go ahead and multiply it. But at least we know at the end we won't have to do any reducing because we've tried here. So we're going to multiply the tops, we'll multiply the bottoms. So up top I have 4 times 71. I'm going to do this mentally. I'm going to break 71 down. I'm going to split it apart in my mind into 70 and 1. So it'll be 4 times 70 and 4 times 1. So 4 times 70, that's like 4 times 7, 28, but with an extra 0. So 280. 4 times 1 is just 4. Put the two of them together, 284. On the bottom, 5 times 1 is just 5. Now, what do fractions mean? Fractions mean division. So to do this, we're going to go ahead and divide. And I'm going to, instead of doing this one in my head, I'm going to do a little short division underneath. So remember, everything nice full-size numbers. Use the whole space here. I'm going to divide this by 5. So we go each digit, remember. 5 goes into 2, not at all. So we're just going to move on then to the 8. 5 goes into 28, 5 times. Now for short division, we're going to do some little bit more calculations in our head. So 5 times 5 is 25. And if I take that away from 28, we will have 3 left over. So remember, in short division, we bring over what's left over instead of bring down the next digit. So now this is a 34. 5 goes into 34 6 times, because 6 times 5 is 30. So if I take 30 away from that, I'll have 4 left over. Now I don't have another digit here to put. I could put in a decimal and then put in as many zeros as I need, or I can just take that leftover 4 and make it my numerator. The denominator will be what the denominator used to be. It'll be what we're dividing by, the 5. And so my answer here is 56 4/5. So what this tells me is, what number is 4/5 of 71? 56 4/5. So if we were to take 71, break it up into 5 equal pieces, and then put 4 of those pieces together, those 4 pieces together would be 56 4/5. Let's take a look at B now. So for B says 75 hundredths of 14.4 is what number? So if we translate this, first of all, 75 hundredths could go one of two ways. We could write 75 over 100 and write it as a decimal, but then we'll have a fraction, or excuse me, write it as a, I could put 75 over 100, write it as a fraction, but then we've got to multiply it with the decimal 14.4, and that doesn't work out super nicely. We can do it, but we'll have some extra steps in there. Or we can just realize that 75 hundredths means that hundredths is a decimal place. Specifically, if you've got 100, 100 has 2 zeros, so the hundredths has 2 decimal places. So we could just make this a decimal with 2 decimal places and put a 75 in. And I like that best, because if I have a decimal with 2 decimal places and I put a 75 in here, that is 75 hundredths. Now moving on, it says of. Of means times. And then 14.4 must be my whole thing. After 14.4, we see the word is. Remember that is always means equals. And then it says what number. So that what number must be then the part of the whole that we're trying to discover. So if we find 75 hundredths of 14.4, what will that be? Essentially what we're asking is, if we were to break this up into, because there's 2 decimal places there, 100 little pieces, equal pieces, and then take 75 of them, how much would we have? So there's my equation. That's my translation. Now to solve this one, when I look at this, I'm probably going to end up doing this vertically. So I'd like to keep this space right here open for writing my answer. So when I go to do this, I'm going to put it out of the way. I'm actually going to take this over here. Now in multiplication, we know that we can do this in any order. We can do this the first number and that the second number, or we can put this the first number and that the second number. So if I'm doing it vertically, I would rather have the most number of non-zero digits on top and the least number of non-zero digits on bottom, because that's going to mean a little less writing and a little less work for me in the end. So I'm going to put 14.4 on top. I'm going to put 0.75 on bottom. Now you'll notice, ladies and gentlemen, that I did not line up my decimal. Remember that multiplication is the only operation where we do not need to line up the decimals. All the other operations, addition, subtraction, division, it lines up, but not with multiplication. Multiplication's special here. Okay, and we'll get to the details of that here in just a second. So the first step of multiplying 2 decimals is we're going to multiply these like they were whole numbers. So 144 times 75, which means we can actually just ignore this 0, pretend it like it's not even there. So here we go. 5 times 4 is 20. I'm going to put the 0 down, carry the 2. 5 times 4 is still 20, but plus 2 is 22. So I'll put a 2 down, carry a 2. 5 times 1 is 5, plus 2 is 7. Remember that when we move on to the next digit, since we're over here now, we've already done this, so this space is done. We did the 5, we're on to the 7. The 7 starts here. If the 7 is here, its multiplication results start here. So that's going to be a placeholder 0 there. Here we go. 7 times 4 is 28. Put an 8 down, carry another 2. 7 times 4 is still 28, but plus 2 is 30. So put the 0 down, I'll carry a 3. 7 times 1 is 7, plus 3 is 10. And since that's the end of it, I'll go ahead and I'll just put the 10 down there. Again, there is no need to multiply by this 0, because if we're multiplying like a whole number, well, if this is a whole number 75, that wouldn't be there. You can just ignore it. Now, if you don't, all you're going to end up with is a bunch of extra zeros here that in the end, when you add them together, aren't going to do anything. So it won't hurt anything, just it's unnecessary writing. So now we add it up. 0 and 0 makes 0. 2 and 8 makes 10, so put a 0 down, carry the 1. 1 plus 7 plus 0 is 8. And then I got a 0, I got a 1. Now this is where we need to look at those decimals. So when I look at this decimal now, remember that we have to count these up. So when I look here, I've got 1 decimal place. So this has 1 decimal place. This here, though, has 1, 2 decimal places. And so therefore, the answer needs to have the combined total of these. The answer needs to have 3 decimal places. So that'll be 1, 2, 3 places right there. So the decimal needs to go in front of those 3 places. Now this is a point where I see students often have a lot of confusion because some of you know that what we're going to do next is we're going to drop these 2 zeros off because we don't need them. So these extra zeros after the decimal, after all the other digits that aren't 0, these extra zeros can be dropped. However, we don't drop them until there's a decimal in place. I get a lot of students that want to drop them early and then put your decimal in over here. If I go to my dry erase board here real quick just to illustrate what I'm talking about. So when we do this properly, as we just did, we should be taking that right there and we should be counting. This is 1, 2, 3 spaces. We put our decimal in, and then we say that the final answer is just 10.8. That's correct. But the big mistake I see a lot of students make is they get ahead of themselves and they say, oh, we're going to drop these off anyways. So let's drop them off, and then let's count 1, 2, 3 spaces. And they put their decimal right there. And they say the answer is 0.108. This is wrong. This is right. This is wrong. So, and just to show a little bit of a difference here, if I were to go ahead and put a dollar sign in front of each of these, this one right here would be like having $10.80, whereas this one down here would be like having, if we round it off, 11 cents. Hopefully you can see there's a big difference between these two different answers. So ladies and gentlemen, remember, when we're reducing decimals, reduce once it's actually a decimal. If you haven't put the decimal in yet, there's nothing to reduce. Keep those zeros till you put the decimal in. All right, so anyways, back to it. So as we just talked about, we're going to reduce this decimal. So my final answer I'm going to put up here with the variable. And so my final answer is 10.8. So What is 75 hundredths of 14.4? Well, if you take 14.4, break it up into 100 equal pieces, and you take 75 of those pieces and put them together, it's going to be a total of 10.8. Moving on to our next problem, let's take a look at C. So for C, here, what number is 50% of 150? So what number is 50% of 150? So first of all, it says what number. We don't know what that is. So you know what, this time, I'm not going to actually worry about which part of the problem it is. I'm just going to call that x. We don't know, so I'm going to call it x. Next says is equals. After the is comes 50%. Well, that's a number. Let's just write it. After 50%, it says of. Of means times. And then 150. So, ladies and gentlemen, in order to figure this one out, we're going to have to kind of do a little side problem here. So with percentages, we don't usually just do it. Percentages tell us that we'd have to break this up into 100 equal pieces and then take 50 of them. But we often think of that more in terms of either a fraction or a decimal. So right here, this wouldn't matter if we went fraction or decimal. I'm actually going to take this over here. And I know this one is easy enough that you could just probably do this one in your head. But remember, the purpose of doing our work is practicing how to do these things on the easy problems so that when the hard problems come along, you know what to do. So yes, even with things like 50%, I want you to show your work just to practice what to do so when the hard stuff comes, you're all set. So 50%, remember percent means per, divide, cent, 100. So 50% is 50 per divided by cent 100. That is literally what it means. Now from here, you can change this to a fraction, you can change this to a decimal. Personally, I think that this is going to be a little bit easier to change into a fraction. So what I'm going to do is I'm going to come down here and I'm going to say then that this is 50 over 100. Because remember, every division problem can be turned into a fraction. So first number over the second number. And then 50 over 100, of course, reduces to 1/2, which I'm sure you guys knew right from the beginning. All right, let's come back over now. So what we've just shown here is we've just shown that 50% is the same thing as 1/2. So in mathematics, anytime two things are the same, we can replace one thing with what it's the same as. That's what we did here. We replaced the percent sign with what it's the same as, divide by 100. Now I'm going to replace the entire 50% with 1/2. So this becomes x equal to 1/2 times, now 150, let's think about this. We got a fraction now. How about we change 150 into a fraction as well by putting it over 1. From here, we can do a little reducing before multiplying. Maybe you know that 2 goes into 150 75 times. I got a lot of 1s there and a 75. Well, 1 times 1 will be 1, so we know our answer is going to be a whole number. And that whole number is just 1 times 75, or 75. So what number is 50% of 150? 75. And you could do this likewise with a decimal, where instead of making a fraction, you just turn this into 0.5. And the only difference here is then this would be 0.5 times 150, and you got to figure out what that will be by multiplying your decimal with your whole number. But otherwise, it's the exact same problem. I'm running out of room here a little bit, so I'm going to go to the back. I'm going to start D right here. So for D, 3%, well, stop right there. That's what it said. Let's write it. Okay, So what about 3%? Well, 3% of, stop right there. What does of mean? Times. Okay, back to the problem. 3% of $39. Let's write that. Great. 3% of $39 is, stop there. What does is mean? Equals. 3% of $39 is how much money? Now, we don't know how much money, so we could go through and, obviously this would be our part. We don't know what part this is, but I'm just going to go traditional here and just go with my x this time. Now here, we have a percent again. Last time we chose to go with a fraction. This time, however, since we're dealing with money, we almost certainly want to go with a decimal. We don't do fractions when it comes to money. We do decimals. So it's kind of a good rule of thumb. You got a fraction, do a decimal. So I'm going to just kind of come over here again like I did last time. Get this out of the way. So 3%, literally remember, percent means divide by 100. So this literally means 3 divided by 100. I come back to my dry erase board for just a quick second. I'm going to erase that. Remember, ladies and gentlemen, that whole numbers have a decimal place after themselves. It's invisible, but it's there. And then remember, ladies and gentlemen, when we divide by 100 or divide by 10 or divide by 1,000 or a million or a place value in general, we simply move the decimal. If we're dividing, it's going to make the number smaller. We're going to move it the same number of times as we have zeros. If we're multiplying, it'll get bigger. And again, we'll move it the same number of times as we have zeros. So I'm going to move this decimal 2 times, and since it's division, I'm going to make this smaller. So this would make it smaller by 1 place. This would make smaller by a 2nd place. So when I divide this by 100, my decimal goes right there, and I'm going to fill in the empty space and the front of the decimal with zeros. So back to my paper here. 3% is 3 divided by 100, which is 0.03. So over here, I'm going to replace 3% with what we just discovered, times $39 equals x. And now we got to figure out what this is. So there's no way around it. We're just going to have to go ahead and multiply that. So I'm not going to worry about the dollar sign. We'll put the dollar sign on at the end. I'm just going to come over here and figure out what is 39 times 0.03. Remember, when it comes to decimals, we multiply as if these are whole numbers. So I'm putting the 3 on the bottom here, the 0.03 on the bottom, because if this is a whole number, it would just be the 3. If this is a whole number, it would just be the 3, which means these 2 zeros wouldn't be here. So all I got to do here is multiply by this 3 and then figure out where my decimal goes. So 3 times 9 is 27. Put the 7 down, carry the 2. 3 times 3 is 9, plus 2 is 11. That's all the multiplying I have to do for this problem. Now I do have to figure out where the decimal goes. So here, since this is a whole number, this has 0 decimal places. This guy here, because we divided by 100, we ended up with 2 decimal places. And so that's going to make a grand total of 2 decimal places for our answer. So 1, 2. So therefore x must be 1.17, but the dollar sign will tag along. So $1.17. And again, to understand the meaning of this, since it's a percentage, percentages are always about cutting things up into 100 equal groups. So if we took $39 and cut it up into 100 equal groups, and then we took 3 of those groups, it would total $1.17. So obviously not a lot of the whole $39, just a small piece. And then we're going to go ahead and get just one more in for today. We're going to take a look at E. E. What number is 25% of 64? What number is 25% of 64? So here we go. What number? We don't know. Is equals 25%. Write it. Of means times here, and then 64. Write it. That's your equation. So now, if we go ahead and we tackle this guy, I'm going to come over to the side here, and I'm going to take a look at 25%. And again, I'm fairly confident that many of you already know what this is, either as a fraction or as a decimal, probably both. However, practice for the hard problems. So 25% means 25 divided by 100. Now we got to decide, do we want to go fraction, do we want to go decimal here? You could go either way. I'm going to choose a fraction here just because I know what's coming. If you didn't and you went with a decimal, that would be perfectly fine too. So, but I'm going to go with a fraction this time. So this would be 25 over 100. And then obviously 25 goes into both of those. It goes into the top once, goes in the bottom 4 times. So this is 1/4. So x therefore equals 1/4 times 64. But hang on. Let's change that into a fraction too. So 64 will be itself over 1. And now this is the reason why I chose to go with a fraction, because I recognize that 4 actually goes into 64. And you potentially could too. Because you know in the clock that a quarter of an hour is 15 minutes. So 2/4 of an hour, or half an hour, is 30 minutes. 3/4 of an hour is 45 minutes, but the whole hour is 60 minutes. That's 4/4. So we know 4 goes into 60. Well, you also know that 4 goes into 4. So if you use that, 4 goes into 60 15 times. 4 goes into 4 once. 15 and 1 makes 16. So 4 actually goes into that 16 times. 4 obviously goes into itself once, a little reducing before multiplying, and we have a really simple answer here. So our answer, all ones on bottom means is a whole number. So 1 times 16 is 16. So what number is 25% of 64? 16 is. And that, ladies and gentlemen, is the end of our lesson.